at the support@cellulardynamics.com address, as well as then at Ben's address at NeuroProof. And so I think for questions, we don't have any additional right now, but if you have others, please feel free to send our way, and we will get back to you with the right information then.
Thanks, Kevin.
Yep.
Yep, thanks, Kevin. And so I think in closing, I'd just like to mention that this webinar will be up on our respective websites, and when that happens, we'll send out a group email to all the registrants to let them know when that's there. So with that, I'd like to thank Dr. Bader and NeuroProof for hosting us here and for participating in the joint webinar. So thank you very much.
Thank you.
Thank you, everybody, for joining us. I wish you all a good week and a good December. Thank you much. Bye-bye.
Bye-bye.
This will allow us to rapidly triage compounds prior to going
going into animal models for pharmacology and safety, as well as enabling studies of mechanism of action. Over the last 6 months, we've been building a more robust cell biology platform at MyoKardia. Early on, we had developed extremely useful high-throughput biochemical screens for activity and had very relevant and effective animal models. In our biochemical screens, we could screen thousands of compounds, but in between our hit to lead screening, we had a very low throughput primary myocyte assay. This assay is very data rich and gives us insights into contractility with readings of amplitude, rates and velocities, and contraction and relaxation, calcium handling, but it's just not scalable. So it, in fact, created a bottleneck for us. What we really wanted is to develop a cell biology platform that would provide a testing funnel for us. To help take us from hits to leads, we wanted to build a testing funnel that would take compounds through increasingly complex studies that would begin with a higher throughput assay for effects of contraction and safety, then on to force measurements, and finally through into primary myocytes if necessary. We used our myocyte assay to inform what kind of information that we wanted to be able to acquire from our testing platform, to include contractility data, contraction and relaxation velocities, off-target effects in terms of effects on sodium, calcium, potassium, or hERG channels, as well as information about hypertrophy and viability. Those would be excellent additions. As we set out to build our platform, we evaluated different technologies to decide what was truly fit for purpose in this situation. We've looked at microtissue technology, in which we can use iPSC-derived myocytes to form tissues attached to two posts to be able to directly evaluate contractility force in a loaded system. We also assessed the utility of MEA devices that can only detect field potential. In our myocyte assay, we currently utilize a video capture system, and we also started looking at other options which might add higher throughput to this primary cell assay. And importantly, we also evaluated the ASEA Cardio ECR, which can give us measurements of impedance and field potential. The Cardio ECR E-plates have wells that are the same size as a 96 well plate.